Now we have the lesson 34 homework ready. Let's give it a demonstration. Notice that it comes up that it's in the arm mode and it's waiting for something to happen. So let's disarm it. If we disarm it, we press the B button and enter. And then it asks for a password. So we enter the password, which is now 1, 2, 3, and enter. And we see that it's no longer armed. If it's not armed, we can change the password. If we go to enter a command of C, enter, it asks for your password, which is now 1, 2, 3, enter. And it asks for a new password. Let's make it 3, 2, 1, enter. So our new password is now 321. Let's arm it by entering an A. We see now it is armed. If I try to change the password by entering a C, it doesn't allow it. It just still asks us to enter a command. So let's disarm it by entering a B, enter, asks for a password, enter password, which is now 3, 2, 1, enter. Oh. It didn't hit the enter. Now it's not armed, so we can change the password by entering. Well, let's, instead of doing that, let's arm it. We see the system is armed again. Now let's disarm it by entering a B and a D. Enter password, which is 3, 2, 1, enter. So you see the system is not armed. So the system seems to be working well. This is the code used in the homework for Paul Mcwhorter's lesson 34 on the Raspberry Pi. At the top are lines to set up the libraries, and Paul has covered those pretty well in his tutorials. So I'm not going to go into those in detail. The second set of items here are variables that I've set up. I set the keypad state to 0. That means that's telling the thread that we'll see later that the system is waiting for keyboard input. I set up the arm state as a 1. That means that the program starts in the armed state. If it's a 0, it's disarmed. I set a keypad string as an empty string initially. And the password, the default password at startup is 123. This can be a problem. If the system reboots because of a power glitch into the program and the user has changed the password, the user may not be aware that the password has changed. A better way might be to put the password in a separate file, and when it's changed, write the new password out to the file. The next function is set up as a thread, and this is the function that continuously looks for input from the keyboard. If the keypad state is 0, that means it's okay to read information from the keypad. If it's a 1, that means the program is processing the string that was provided earlier. So let's go down to the main part of the program. We'll look at the other functions later. When we start entering the program, we set up that first function as a thread and get it started. Then in this section, we write out some information to the LCD screen, telling the user that it's waiting for an input command and that the system is armed. Then we have a try loop that keeps waiting for input. When it sees input, it checks to see if it's an A, which means arm the system. Else, if it's a B, we want to disarm the system. If it's a C and it's not in the arm state, we want to change the password. You can't change the password if it's already armed. And if it's none of those three, then we just go back and write out the message to input a command, set the keypad state to 0, and go on. Now, let's go look at the functions. If it's an A and he wants to arm the function, we go up to the arm function, and we see that all this function does is set the arm state to 1 and the keypad state to 0. It tells the thread that we're waiting for input, and write out the message in the second line that the system is armed. Later on we will have implemented something to sense a security breach, and that will know whether or not it's armed and continue checking the sensors. If the input is to disarm, the user first needs to get a password. It calls the password function, and if the read password function returns a true, we set the arm state to 0. That means it's disarmed. We set the keypad state to 0, and we write out the message that it's not armed and return. Now this function calls another function called read password. If we look at that, you'll notice that in these functions, I've set up the variables that I used earlier as globals. So when we enter the read password, we set the keypad state to 0, and I allow the user several tries to enter a password. So he gets the message, enter password, and if it's less than the number of tries, it sits there, and if it sees the keypad state as a 1, it first prints out this print message. Is for debugging. It asks if the keypad string returned is equal to the current password. If it is, we set the keypad state to 0. That means we're waiting for input, and we return a true. If it isn't, we bump the number of tries, set the keypad state to 0, so we can try this over and over again until we've exceeded the number of tries allowed. If it fails to enter the correct password, we go back and write out the statement, input a command, so the system is sitting there waiting for another command to be entered. On the change password, if the user has entered a C
and it's not in the ARM state, it goes to the change password function. And in the change password function, it looks here to read the current password. And if that has returned a true, then it can say, well, enter a new password. We set the keypad state to 0 again. And this little loop here just waits for the thread to tell it that a string has been entered. Then when it has been entered, we set the new password to the string that was entered. We set the keypad state back to 0. It means we're waiting for input. We briefly write out this message that it has a new password. I sleep for a couple seconds and then overwrite that with the input command statement and return. So that pretty well covers the code. The one thing that is lacking is in the accept keyboard interrupt. I haven't yet figured out a graceful way to exit the program with the thread. So I get error messages when I do a Control C to exit the program.